All right, so let's talk about exceptions. Now, what are exceptions? Well, if you've worked with any software development language before, you will know what exceptions are. Basically, exceptions are some errors that happen during the execution of your program. So errors that happen during the execution are called exceptions, okay? So to give you some examples, an exception might happen, for instance, when you're trying to access an index that doesn't exist in a list, or a key that doesn't exist in a dictionary, or when you're trying to convert from a string to an integer when the string doesn't contain the right kind of information, and so on. So there are many ways that exceptions can occur in our programs. The main idea behind this series of lectures, the videos, is that there are ways to manage exceptions that might occur. Okay, so we can do something about it. We don't really have to let exceptions happen whenever they happen. So the main point is that the system cannot recover from an exception, right? So your program will stop and an error message will be displayed, or if you are hiding any display message, then nothing will happen and your system will simply crash. The reason that we don't really want exceptions are multiple, but one of the most important is that data is lost and the program stops, right? So anything that isn't stored in any sort of persistent way is lost. So data that is in memory is gone and there is no way to recover that. Exceptions cause very bad user experience, right? So a user that is running your program, that is using your program, and that happens to have an error, the execution will stop and that user will have a bad experience. We'll have to restart the program and redo all the steps that have been lost in the meantime. Now, exceptions have a message, so it is important sometimes to use that message to diagnose the problem. Now let's go ahead and have a look at some exceptions that might occur. So for instance, in this case, we are asking the user for a number and we are trying to convert that input data into an integer. However, if the user enters a string that is not a number, then we will get what we call a value error, and the message for the value error says invalid literal for int. Okay, so let's try that out in our code. So I'm going to say data equals input. Please enter a number. Okay, now number is going to be int of data. So if that data is not a number, then we're going to get an exception. So please enter a number. I'm going to enter test and we will get a value error. Okay, an error or an exception are pretty much interchangeable, right? So this is an exception. We have invalid literal for int with base 10 test, okay, because we did not enter a number when that was requested. So that is the main idea with exceptions. They can happen at any time. If you want, you can take another example here. So let's say we have a list of our numbers 2, 3, 4, and then let's see what happens when we are trying to print list of index 6. Okay, the index 6 doesn't exist. Let me just comment out the first part of our code. And then if we run that, we get an index error, list index out of range. Okay, so there are many ways to generate exceptions. These are just 2 examples. And in the next video, we will learn how we can manage these exceptions and not let them completely stop our program execution. All right, so the main mechanism with which we can manage exceptions when they occur is with the try except block. Okay, so this is a way to manage exceptions. So here is where we would generate an exception, right? We have our fruit banana, and if we try to convert that variable into an integer, then we will get a exception, and our program would crash. The way we handle that is we put the code that might generate an exception inside a try block. So we have the keyword try, colon, and then we have a block of code. Now, if an exception does occur, the except block will be called, and then an we can handle that in any way. In this case, we print an error has occurred. So let's try that out in code. Let's say fruit equals banana, and then we try to convert our fruit into an integer. Okay, now this will fail for sure, we know that, and we're going to catch that in an except, and we're going to say print an exception has occurred. Okay, and if we print continuing the program, okay, if we run that, we can see that an exception has occurred, of course, at this level. Okay, and then we are continuing with the program. So the exception at this point is no longer stopping our program from executing, right? Even if an exception has occurred, we have handled it and the program is ready to move on with the next execution, right? So we try to run some code. If something happens, we handle that and execution can continue. So that is the main mechanism with which we can catch exceptions. Now, of course, there are multiple details to this mechanism, like we can handle multiple types of error and provide different functionality for each individual case when some particular error might occur. So here's an example. Let's try to convert our fruit into an integer. Let's say we have an exception name error. So if we don't actually define this fruit, then we will get a name error and we will fall into this block of code, right? So the basic structure is in except we can provide the type of error that can occur and that will be caught. Then we can provide another type of error and we can provide some functionality for that particular case, right? So we can print a more personalized message. And then if none of those occur, then we can catch any error that may happen in an except without the type of error, right? And here we can print something like a generic error has occurred. So let's try that out for ourselves. I'm going to comment out this part of the code and I'm going to say try. Now I'm going to convert int my fruit variable that I haven't actually defined. Okay, so I'm going to accept value, not value, name error. Okay, so in this case, I can say something like a variable is not defined. Okay, I can catch the exceptions of type value error. And in this case, I can print something like cannot convert variable to int. Okay, and then I can catch any exception that might occur apart from those two. And here I can print a more generic message, a generic error has occurred. All right, there we go. So if we run the program like this, we will get variable is not defined because we haven't defined the fruit variable. But if we define our fruit variable here, banana, okay, then we fall into the cannot convert variable to integer exception, right? So we are trying to catch that type of exception. However, let's say we have 45, okay, but I am trying to access the fruit index number 5. Then in that case, we will fall into this generic exception, and we can say generic error has occurred. So it really depends on which kind of errors you are expecting to happen, that have a possibility to happen at a certain level in your code. You might want to provide functionality for those. Or if you are simply expecting a generic error but do not know which type of error you might encounter, or if the way to handle any error is the same, then you might want to provide a default case here like that. So this code defines specific errors, and otherwise we have a default case to handle any exception. Now there is a message, like we said, to each error, okay, and there is a way to catch that exception message. We can say accept value error as E, okay, and E will contain the message from that error. So we can say an error has occurred, and we can print out the message that was given to us. So if I say here banana, and here the value error as e, okay, cannot convert a variable to int, I'm going to put a /n, or actually I can put another print line here. I can say, let's say e. Okay, so let's go ahead and run that, and we get invalid literal for int with base 10 banana. So that kind of is a bit cryptic, so a regular user wouldn't really understand that. Us as developers, we might understand what it means, but if you want to provide some error messages for the user, you might want to reconsider using the error message and provide your own in this way. So there we go. That is the way we can handle different types of exceptions at certain levels in our programs. All right, so the try except block also can have a else block attached to it, right? Like now we've seen the else block previously in our course when we were talking about if conditionals and for loops. Okay, and here it kind of has the same purpose as it did back then. So the main idea behind an else block is that it is executed if no error has occurred. Okay, so it allows us to provide some functionality in the best case scenario when nothing bad happens, right? And here is how we can use it. Let's say we are asking for some data from the user. We are trying to convert that data into an integer. If an exception occurs, we intercept it, else we can print correct type of data was introduced. Okay, so it allows us to provide some functionality in case no error happened. So let's try that out in our code. We're going to say data equals input, please enter a number. Okay, now we're going to try to convert that data into an integer. We don't really capture that information in a variable because we're not actually using it. Now, except that you might get an error, so you can simply print an exception has occurred. And we have an else block where we say print correct type of data was introduced. Okay, so there we go. We have either the exception or the correct best case scenario. So let's run this. And first of all, I'm going to introduce a number, and we get correct type of data was introduced. However, if I introduce the wrong type of data, so just a random string, I will get an exception occurred, and the else block will not be executed. All right, so if an error occurs, the else block will not run, which is the same functionality really that we got in the for loops, right? So in the for loop, we would have an else block that will run if the loop continues correctly until the end, if no problems happened or the loop hasn't been broken, right? And it's the same idea here. If nothing bad happens, then the else block will run. If an exception occurs, then the block will not run. So next up, we're going to talk about the finally block, which is another component of our exception handling mechanism. Now, the finally block will be executed whether or not an exception occurs. So basically, we can count on the code in the finally block to be executed at all times, right? So whether or not an exception occurs, we will be executing the finally block. And this is a very useful functionality to have in the case where our code uses some quite expensive resources, and we want to, whether or not we have an error with using those resources, we want to free up the memory, free up those resources at the end where we finish using them, right? So very, very important. And this is used quite extensively in, in your everyday programming. So here is an example. We have the typical input information from our user that we're trying to convert to an integer, and we will catch any exception. But importantly, the finally block here will always be executed. Okay, so let's go ahead and try it out in our code. I'm gonna say again, data equals input. Please enter a number /n. We're gonna try to convert that to an int. We're going to have an except print an exception has occurred. And then we're going to have a finally block that will print this will always be executed. Right, so whether or not we get an exception, this will run. So let's try it out. All right, so first of all, I'm going to enter a number, 23, and then we see that the block was executed. And then we have a text, a random text, and we get the exception. So we handle that exception, and we get this will always be executed, right? So you can leave this out if you want to. It's usually a good idea to put it there. If you are using resources that might generate exceptions, it's usually a good idea to release those resources when the execution completes, right? So finally, very, very useful block of code. Like we said, useful for cleanup and resource deallocation. All right, so in addition to managing system-raised exceptions, so exceptions that might occur during the execution of our program, we have also the option to raise our own exceptions. Okay, now ordinarily we might not want to do this in our own code because any exception that we raise could potentially be handled in our own code. However, you can think about a situation where we are developing a library of functionality that will be used by other third-party developers, right? So in that case, if something occurs, if some information is inserted into our functions, is given to our functionality to process, that type of information is incorrect, we might want to raise an exception to alert the third-party developer that something has happened, right? Or we are a third-party developer and we are trying to raise exceptions if we are using some code that doesn't really match with what we're trying to do. So knowing how to raise exceptions might come in useful at some point. So basically, it is a way to generate our own exceptions, and it can be used if we detect a state in our program that we cannot recover from. If it's something that really is out of our control, then we might want to raise an exception to the library that has generated that state. Okay, it really depends on how we are handling that case, but one of the options is to raise an exception. To raise an exception, we have the keyword raise. Okay, so here is an example, raise value error, and we provide the message that we want to pass to that error. Okay, so let's try that out. We're going to say raise value error, and we can provide a message, value is incorrect. Okay, whatever that means. All right, so let's run that. We get value is incorrect as a exception in our code. Now, there is, of course, a way to create our own exceptions, so to generate our own type of error here, but we haven't really studied the object-oriented part of our programming in Python yet. Okay, so when we study that part, it will become quite self-evident how you might go about creating your own errors. But for now, we are limited to the errors that already exist in our in Python, right? So don't worry, we will shortly arrive at the part of our course where we are talking about object-oriented development, and we will see how we can create new types of errors as well. All right, welcome back to the course. Now in this video, we're going to look at debugging and different techniques, how we might find any errors in our code, or simply looking through our code at execution time, at runtime, to see any values that our variables might have. Okay, so we've already discussed the basics of debugging. If you haven't seen that video, go back in the course on I think it was section 5 or section 6, where we talk about getting user input. At the end of that section, we have a video on debugging. So if you haven't seen that one and you don't know what debugging is, go have a look at that one first before we go into the details of this video. All right, so basically debugging is a way to navigate through code at runtime, so on code execution, and find any issues that may occur. So we can see variables, we can see expressions, we can try different things while we are debugging our code. So before this video, I have an article where I post this code. Okay, so we will be using that code in our debugging exercise in this video. So go ahead and copy that code, put it in your editor, and we'll take it from there. So here I have the code in my editor, right? So the code is quite simple. Basically, we are generating a number. We have a function that prints out a message a certain number of times. Okay, so we have a saying hello this amount of times. We are looping through that and we are printing that message a certain number of times. And we are calling that function 2 times, one with the number generated and another one with the actual, with the number halved. Okay, so we have 2 messages, hi and hello. So let's go ahead and run our code first and see what we get. So let's say randomly we generated the number 9, and then half of that is going to be 4. We are doing a floor division here. All right, so that is the code that we are working with. Now, let's say we don't really have a error in our code at the moment. Let's say we simply want to have a look through our execution time and see any, let's say, values that our variables might have and how the program really executes. So the way we do that is we put a breakpoint at the line where we want the code to stop. I'm not going to put it here. I'm just going to put it here on the first call to the say hello function. And I'm going to right click and select debug. Okay, debugging is the name of my file. So click on debug. Okay, so that will run our code and it will stop at the level where we said we wanted it to stop. And we can see down here that we have our variable number that was generated randomly, and in this instance it has a value of 7. Okay, so we have a couple of options here. One is we have our step over, which will simply skip to the next line of the code. So if we click on that, we will go to the next line, and if we click on that again, the code is finished and we have our messages here in the output. Let's run that again as a debug. Okay, so we are back at this line of code. Now we also have the option to step into. The step into will go inside the step that we are on. In our particular case, we have a function call. So the step into will go inside the function. So let's try that out. We can see that we are inside the first line of our function. So now if we step into, we do not go further down because print is a function that's part of the Python system. It's not something we define, so we cannot look through that. Okay, but we can, of course, step over, and that will take us through our loop. So for us, the times is 6. Okay, so we will loop through our loop, our for loop 6 times. Okay, so if I go step over, I will go into the print and then out back into the loop, and the print again and again. We can see the I variable here has taken the value 1. So initially it was 0, now it is 1, then it goes to 2, and then 3, and so on and so forth until it reaches 5. Okay, so for 5, at which point it exits the loop, and then since it's the last line of our function, it exits the function and it takes us back to this element. Okay, so if we click step over, then we are going to the second second call of our function. Now I want to show you something, another option that you have here. Let's go inside that loop, so step into. Now let's say we are in the loop and we are happy with the functionality here. Well, we have the option to step out of the loop, of the function. So that means it will simply take us out and back to the call of that function. Okay, so these are kind of three buttons, three options that we have to navigate in our program in and out. Okay, very, very useful, and they are often, indispensable. Now, here on the right-hand side, let me just finish running this program and debug it again. Okay, now I will go into my function here. So here on the right hand side, I have the watches. Now here I can put some variables that I want to watch. So for instance, here I want to put times. Okay, and if I step out of the loop, that times becomes not defined. If I go into the second loop again, okay, into the second function call, times again gets a value. But here I can also evaluate some expression if I want to. Okay, so for instance, I have my variable message. Okay, now I want message dot upper. Okay, and here we can simply evaluate any Python line of code in this way, right? And we can maintain that expression, those watches, as long as we want to. Okay, so this is really useful when you're trying to simply produce some expression, some result from the variables that you have in your code. All right, so those are the main topics that I wanted to cover here, the way we can navigate through our loops, through our functions, and through our lines of code, and also the watches section where you can add and remove. By the way, this is the remove button, so we can simply remove a expression from here. So the watches, you can add or remove variables and expressions that you can maintain while you're in the debug mode. All right, so in this video, we're going to talk about the with keyword. Now, the with keyword is sort of a compound keyword, which basically allows us to perform two operations at the same time. Okay, so it allows us to not only open a resource, and we will see shortly how we do that, but it also allows us to close automatically a resource after we use it, right? So we said in the previous video, when we talked about the finally block, basically the finally block allows us to perform an operation or several operations, whether or not we get an exception. And that is really useful for situations where we are using system resources, communicating with some other part of our code, opening files, opening database connections, things like that, right? So these are resources, and it really is very important to handle these in a responsible way. So basically, when we open them, we have to always finish by closing those resources. Otherwise, we will have a lot of problems in our code, including things like resources that aren't updated, resources that are locked, memory errors, and so on, right? So the with keyword is sort of a shortcut that allows us to open a resource, use it as we want, and then automatically close it without us having to worry too much about that. So basically what it does, it eliminates the need for a finally block. Okay, it's basically a shortcut to not add the finally block. Simply close all the resources that have been opened. And here is how we do that. So this is an example of how we might open a file. Now, keep in mind, we haven't yet studied files. We will do that in a future section. That is very important. But for now, what I want you to focus on is the structure of our code and not the actual methods or functions that we use to handle the files. So to handle the files, we use three methods here. First of all, we have the open method. We have the read method, which basically reads all the content of a file. And then we have the close method, which basically closes our resource, right? So these are the standard methods for working with files. They are very easy, very simple to use. What's important here, I don't want you to focus too much on these methods. We will study them in detail in a future section. But what I want you to focus on is the structure that we have for our code. So we have a try, we have an open file here, Okay, so in this case, if the file is not does not exist, then we would get an error. Okay, so we catch that error in our except block, an error occurred, and then whatever happens, we close that file. Okay, so basically, if the file does exist and we open it and we read it, then it is very, very important that we close that file eventually. Okay, we free that memory space, especially if it's a big file. When we try to read from it, we will get a lot of data in our memory. We will have that resource open in our f variable, so we want to eventually close that file. Okay, so first of all, before we move on to the with structure, I want to put in place this little code, put it in our IDE, in our PyCharm, and see how it works. All right, so here we are in our PyCharm. Now I have created a log.txt file, which simply has a test log entry here. Okay, now inside here, I'm going to say try. I'm going to say f equals open, and I'm going to put the file in quotes. I'm going to say log.txt, and I'm going to print f.read. Okay, the most simple thing you can do with a file. Then I'm going to have an except, and here I'm simply going to print an error occurred. Okay, and then I'm going to have a finally, and here I'm going to have f.close. All right, so then if I run this code, I will get the content of that file to my console. So that works really well. We are closing the file, so we are programming responsibly. But the main idea is to replace this structure, to not worry about the finally block and have that done automatically for us. All right, so how do we do that? Well, we have the with keyword here. Okay, so we will again try, because we might get an exception. We will say try with open log.txt as f, okay, as the variable that we want. We say print f.read, otherwise we catch the exception. So you can see that in the second case, we no longer have a need for our finally block. Okay, so let's go ahead and put that in our code. Let me just comment out what we have here. So I'm going to say try. I'm going to say with open, so with the operation that will give me that resource, in our case, opening a file, log.txt, as f, which is the variable that I want. Here I will do the operation that I need. So I'm going to say f.read. Okay, so print f.read. And then I'm going to say except print an error occurred. All right, so if I go ahead and run this code, we would get the same output. So the main idea here is that we are no longer required to have the finally block, which basically closes our resource that we are using, right? And this is very important, especially in large-scale programs where you might open a resource at some point and you want to automatically close that resource so that you don't really need to worry about it later on, okay? If we do a try except finally, then we need to worry that at the end of our, I don't know how many hundreds of lines of code, let's say, once you finish the operations, then you need to close all the resources that you have been using. With the with keyword, it's basically a shortcut that puts that responsibility on the system, okay, so that we don't have to worry about it and let the system know when the with block is finished, then it can close our resources. Of course, this cannot be used in all situations, especially if you have multiple resources that maybe depend on each other, then you might not find it so easy to use. But when we are faced with situations like this small example where we are handling files that can be automatically closed by the system, then we can put all our code inside the with block and not worry about resource management. We just want to perform our operations and have the system do the resource closing for us.